got this curve here, and I'm not really interested in the equation, but there it is. There's our curve. And we want to find the area underneath it. Well, we know we can use integration to find the area underneath the curve. But I'm going to teach you another method in which we can estimate the area under the curve. And this is where today's topic, the trapezium rule, comes in. So we can use this to sort of give ourselves an estimate, but it wouldn't be the exact value. Think of it like the lazy person's integration. So what I'm going to do is I'm going to draw some strips going from the curve all the way down to our x-axis. And essentially what we're trying to do is we're going to make each of these strips into rough trapeziums. So if you take the first one here, we sort of made it into a trapezium, and we're going to try and find the area underneath each trapezium. So we know that the area of a trapezium, if I draw a quick trapezium down here, where the base is equal to h, and then I've assigned two heights. I've got y0 for the shorter height and y1 for the longer height. So we know the area from GCSE, we know the area of the trapezium would be a half h and then y0 plus y1. So y0 is essentially this here. Then the other length of that first trapezium will be y1. And then you've got this length here. So that is the length of the second trapezium on the right hand side. That will be y2. But then you've got this length here. That's y3. This length here is y4. And the other one is y5. Just going to quickly make that look like a 4. That'll do. So after we've found the area of the first strip, how would you find the area of the second one? So we know in the second strip, so it'd be this one here. Well, we know that the left-hand side is y1. The right-hand side is y2. And applying that formula, we would get a half h. Well, now it would be y1 add y2. Okay, so how would you do the third trapezium? Well, going over to our third one, we've got y2 and y3 as our sides. So it'd be a half h, y2 add y3. And this pattern essentially continues until the final strip. So I'm going to quickly finish this off, and you should get this if I zoom out there. So if we solve that formula, then we would get an approximation for the area under the curve. So what I'm going to do now is I'm going to simplify it. I want you to look at y0 and y5. What's so unique about y0 and y5? Well, if you look at y1, y2, y3 and y4, they actually appear twice. Because as you can see, we've got y1, well, that appears twice. We've also got y2, that appears twice, and then y3 and y4. So another way in which we can write this is a half h, and then y0 appears once. And then we can say, well, we know that y1, y2, y3 and y4 appears twice. So we'll do 2, y1, add y2, add, and then however many they are. So we'll do y, to be add yn minus 1. And then here we've used 5 strips. So y5 only appears once. So our last value here would be yn. And that is essentially the trapezium rule written algebraically. So let's have a look at some examples that uses this trapezium rule so we can see it in action. So I've got the graph y equals sec x here. And in the exam, they would give you a table of values. They'll give you a table of x values and a table of y values. And before we do the trapezium rule, the first step we should do is fill out this table. So let's substitute every single x value into sec x to get y. And you can use your calculators for this. So I'm just going to quickly fill out the table. And you should get those values. So all we need to do now is fill in the formula. So what I'm going to tell you is last value is pi over 3. So I'm just going to say pi over 3 is roughly here. So, well, we know that pi over 3 will be our upper limit. This is what we're trying to find, this sort of shaded region here. That's the area we're finding. Well, hopefully you know if pi over 3 is the upper limit, then that is equal to b. And then a would just be 0. So how many strips are we using here? So hopefully you can tell that we are using 4 strips. So we've got from 0 to pi over 12, and then pi over 12 to pi over 6, pi over 6 to pi over 4, and then pi over 4 to pi over 3. Okay, so what we're going to do first is we're going to find h. And we know that h is equal to b, which is pi over 3, minus a, over, and we've used 4 equal strips. And that will essentially tell us pi over 12. The integral from, well, we know b is equal to pi over 3. We know a is equal to 0. Well, we've got half, and we know pi over 12 is h. And then what you do, well, we know y0, our first y value of the first strip, well, that would be 1. And then we do add 2. Well, y1 is essentially 1.035. Add 1.155. And hopefully you get the picture. I'm going to quickly fill this out, and I'll be back in a minute. Okay, so hopefully you got this, and what we're going to do is just quickly simplify it, and that is essentially it. So if we look at this bit here, the stuff in brackets, well, if you quickly punch that into your calculator, you should get 10.208. Then over here we've got pi over 12 times a half. Well, that would be pi over 24. And then you should get an answer of 1.34 to 2 decimal places. And that is essentially an approximation for the area under the curve. This integral here is not really needed because I've just bunged that off. Now, I want to ask you a question. Is our answer, our 1.34, an overestimate or an underestimate? So I'm going to give you a couple seconds to figure that out. And the answer here is that it's an overestimate. Now, a little while ago, I put out a video about concave and convex functions. Now, this graph, y equals sec x, is a convex function because it's sort of U-shaped. And if we were to draw our trapeziums on the graph, well, it would sort of look like that for some of them anyway. And as you can see, these top lines here, these diagonal lines, well, they go over the curve. And if they go over the curve, then clearly we're overestimating. Okay, so I've got another question here where it's the square root of 1 plus tan x. So first thing that we would do is quickly fill out the table. So the next thing that we should do is find h. Well, how many strips are we using? Well, we're using 4 strips. So n would be 4. What would b be? So b is the highest x value. And that would be pi over 3. Because that is our upper limit. And a would just be 0. So let's quickly solve that. we will get pi over 12 yet again. And now we will just use the formula, nice and simple. So we do half times h, well h is pi over 12. And then, well, our first y value will be 1 plus 2. And then we got 1.126 plus 1.256 plus 1.414. Close the bracket plus 1.653. And then what we do is we'll quickly solve this here. And we'll get 10.245. I don't know why the decimal points are so faint, but I don't know. Yeah, and then we look over to this side next. Well, half times pi over 12 is pi over 24. And then we should get our answer of 1.341. And we're done. Easy as that. It's as easy as that. So hopefully you enjoyed the video and found it informative. If so, may I ask you to like and subscribe, and I'll see you in the next one.